So what do we need for this catalyst to be a catalyst?
Needs to affect reaction time,
How?
speeding up, slowing down.
The pen has a low battery? Okay. Speed up a reaction. How so, usually?
Bringing the reactants together.
Oh, no, I don't mean like how does it function, like how much faster?
Depends on magnitude.
Yeah, usually orders.
Catalyst has to be present at the beginning and end of the
Cannot be consumed. Has to be present at the beginning and the end. However much catalyst you put in, you have to have that much catalyst at the end, or it's not a catalyst. Energy level diagram for a reaction, progress diagram for an endothermic reaction. Okay. So, what's going on here? Move. So, okay. This is an endothermic reaction because the products end up having more energy than the reactants do. Can you give me an example of something, an endothermic process? A process that takes energy to do?
You think it's cold, right?
Say again?
Does that mean it gets cold?
No. I mean, it could.
Combustion?
No, but gives off energy. Charging your phone, charging the battery in your car. Photosynthesis, right? Doesn't happen in a closet. Doesn't happen at night. 4 factors. I want to relate it to the 3 parts of the reaction collision theory. All right, so we've got nature. So the nature of the reactants was generally the state, but not necessarily just the state, because you could have a solid be in different forms, and so it behaves differently if it's ground up into a powder versus if it's like a large chunk. We've got, what's the second part? The third one? Concentration. And the fourth one? All right, so how do these relate? So the 3 parts of the reaction collision theory are collide, okay, so the nature of the reactants has to do with the ability of the reactants to run into each other. So if they're gases, they're more likely to run into each other. If they're liquids, they're more likely to run into each other. if I have a very fine powder and it's going to react with something, it's more likely to do the reaction and be able to collide than if the solid is just one big chunk. The temperature has to do with the amount of energy that the product or reactants have. If they run into each other hard enough, then their initial bonds will break, so then they can form new bonds. What's the concentration have to do with? I increase the concentration, I increase the rate of the reaction, but why? As far as these three things on the right go.
More chances for explosion.
Yeah, again, they're more likely to run into each other if I just simply put more of them into a small space, or put more of them into the same size space. And then the catalyst is about making sure that they run into each other with the correct orientation, just lining up the molecules. In the way that catalytic converter in your tailpipe causes the gas particles to, instead of being in a three-dimensional space, they adhere to the surface of the tubes inside the catalytic converter, thereby taking away that third plane of existence. Okay, your body has an enzyme named lactase. What substrate does lactase work on? What's the product of lactase acting on that substrate? Okay, so what's lactase work on? Lactose, that's easy. So when lactase, I'm writing the lactase over the top of this arrow. For what reason? So it's a catalyst and it's over the arrow and it's not a reactant or a product because it persists after the reaction's finished. And so then when I take lactose and I allow lactase to interact with it, what do you get? What are the products? Glucose and galactose. Glucose and galactose. It's not a very famous sugar, but it is a sugar, galactose. It's the reason that milk sugar isn't quite as sweet as fruit sugar or table sugar, the galactose part. So why, what does this have to do with somebody being intolerant to lactose? So if they're missing this lactase enzyme, then the lactose goes through their body. It doesn't decompose into glucose and galactose. So what does it decompose into? What is it that people who are lactose intolerant suffer from? Acne? Really? I didn't know that. That's not what I'm thinking. I'm thinking gas, right? So they're going to make carbon dioxide. That's not supposed to be in your intestines. There aren't supposed to be gases in your intestines. This, not necessarily life-threatening, but this can feel life-threatening to a person. If they haven't drinking, eaten, done anything with dairy for a while, and they like drink a milkshake, feel like they're dying, even though they're not actually dying. Okay.